We are up and recording. All right, so let's turn the page here from where we were at last night. And we are going to jump into something called the angle between two vectors. So this vectors unit is just a whole bunch of formulas. The angle between two vectors is located by the following formula, and that is the vector of each multiplied by itself on the top and the magnitude of each multiplied by itself on the bottom. And we've got a note here that if the dot product between these two, so we're going to be multiplying these out, right? So if that dot product between those two gives you 0, then this formula is cosine theta equals. So if cosine theta is equal to 0, then we're going to be talking about a 90-degree or a perpendicular, or another fancy name they use for that is orthogonal. Bless you, Bronwyn. I caught that on video. So when you're doing this multiplication of these two, this is dot product multiplication. So that's when you multiply two vectors. So that's what we had looked at last video. So I can flash back to that just to remind you guys that when you're doing dot product, that's the multiplication of two vectors. That's going to be the first piece of each multiplied together plus the second piece of each multiplied together. So that's what they're referring to in this. So when we're saying the angle between two vectors, you're going to dot product the two vectors on top, and we're going to find the magnitude of each and see what we come up with on the bottom. Okay, so that said, here's an example problem that would mimic this. So example, let vector u be this, and let vector v be that, and also let vector w be that. Don't really know why vector u is involved in this question. Maybe there was more than one question, but this particular one is just asking between v and w. So you can pretty much exclude that. We don't need that. But let's go through and see what you come up with. So you're doing a dot product of the top two, and then finding the magnitude of each on the bottom. Sama, sure. Okay. All right.
Got it, thank you.
No problem. Okay, so when doing that, here is what I came up with. I've got a dot product on the top. Did you guys come up with 0? for the top of your thing. So from up above, it said that if you get zero, I mean, zero divided by anything is going to be zero at that point. So you can go ahead and say that this would be perpendicular, or in this case, they were asking for if it was orthogonal. So that would be a yes to that question. Any questions on that, guys?
What does
Are
orthogonal actually like mean?
orthogonal is an unnecessary way of saying perpendicular. So perpendicular, orthogonal, or a 90-degree angle all mean the same deal. So if you're getting zero, cosine being zero is at pi over 2, that means your vector is at 90 degrees. So if you have a 90-degree angle, that's what they're getting at. Okay. So this is some review mixed with a little bit of new way of writing stuff, I think. So real quick, this one's definitely review. So find the magnitude of that. So we want to recognize that this is in component form. And when you have component form, they've already done the x2 minus x1 for you. So remember that if you had that, you would do x2 minus x1. The component form already is x2 minus x1. So if you're going to locate the magnitude of the vector and you have it in component form, then just kind of use them and square them and take the square root, right? Okay, so does anybody have any questions on that answer being 6? So if you square both of those, 11, radical 11 squared is 11, and then 25 is 5 squared, and that's the square root of 36, which is 6. All right, the next one. Find the magnitude of the vector and the direction angle theta forms with the x-axis, and then I left out something here. Given vector v, and vector v is negative 7 root 2 comma 7 root 2. Okay, find the magnitude of the vector and the direction the angle theta forms with the x-axis from 0 to 360, given that vector v has these two pieces. So a sketch might not be the worst idea here to figure out where we're talking about. So what do we know here? If the first piece is negative and the second piece is positive, basically what we're talking about is in quadrant 2, you would draw an arrow up that way, and that shows the direction. And then kind of make a triangle out of this. And this is negative 7 root 2. And this is 7 root 2. And then that's your theta. And then just go through from there. And we're going to try to locate this angle. So to locate this angle, we've got some options. You should technically be able to locate it right now. So even though this is a right triangle that we've built, like, could we find the hypotenuse? Yes. But what's going on here? What can you tell me about if the two sides, if the two legs are identical, then you should be able to surmise that we're talking about a right triangle. And if that's a right triangle, excuse me, a 45, 45, 90 right triangle. And if you've got a 45, 45, 90 right triangle, that means you're talking about the 45-degree angle in quadrant 2. So the answer to this is either going to be 135 degrees or 3 pi over 4. depending on the answer choices. Since this was saying 0 to 360, I'm thinking the multiple choice would have been 135 degrees for your answer. And then if it was like 0 to 2 pi, then 3 pi over 4. Okay, let's have you guys try the following. Find the component form of the vector with the given magnitude and directional angle. So we've got a magnitude of 11. The directional angle is pi over 2. And we want to find the component form that would line up with this. Okay, anybody have an answer that they would like to share?
D.
Say that again?
D.
Yeah, D is correct. So when you have that at going to pi over 2, that means you didn't go anywhere for the x. Your thing is 11 in the air. Yeah. All right. Let's see here. I think we are probably pretty good with that one and that one. We've done a lot of those already. That's just magnitude. Let's go ahead and take a peek at this one. Find the angle. Well, we'll just do the whole thing. Why not? So let's just do that example. So you're finding the magnitude for vector v, and then we want to find the angle that v creates with the x-axis. So see what you can come up with. I see two negative pieces to that component form, so that should be a specific quadrant, hopefully. So take a couple minutes and we'll talk.
For B, when we don't have like two different vectors, what should we be looking at for the angle, finding the angle?
talking to myself on mute. Let me try that again. So basically what they're going to ask you with these is going to be some pattern of, so if they're identical, we're talking about a 45, 45, 90. And then the only other pattern that we know that you should be able to pick up on would be, what do we know about a 30, 60, 90 triangle? And that formula goes x, 2x, x root 3. So in the 45 one is x, x, x root 2. So currently you're getting the 45 pattern. So just making something up or trying to make something up, I don't know off the top of my head. If I told you, if one of these was 4 and the other one was 4 root 3, then they're describing a 30, 60, 90, and you'd kind of have to piece together where you're at on the circle and this and that, and it would be, some combo of that. But outside of those ratios, I don't see how you would be expected to pick anything up. So if they're identical, it's a 45. And if it matches in that ratio, we're dealing with 30s and 60s.
Okay, that makes sense. Thanks.
Mm-hmm. Did you guys come up with 225 or 5 pi over 4? Cool. Okay. Let's look at deriving vectors. So good news, it's what you think it is. It's not complicated. So it's just a matter of taking your time and doing the pieces. So if we derive a vector, let vector r equal the position vector, and then you've got the x part and the y part. The velocity vector is just the derivative of each part, and the acceleration vector is the derivative of each part of the velocity vector. So it kind of follows right along. With any time you're stumped with vectors, just go with your common sense, and that should be the correct thing to do. Okay, so a particle travels in the plane with position vector r of t. Find the velocity vector via t. So just keep in mind how we're taking derivatives here. We have chain rule and stuff to apply still. right, and then any questions on that being our solution? Yeah. Let's see. I don't think we need to keep doing these. We'll just talk through them. So here's the position vector. We want to find the acceleration vector. So, I mean, you guys know how to do derivatives. So we're just going to need to do two sets of derivatives, right? The first one would take you to velocity. You do it again. That takes you to acceleration. Easy enough. For this last one here, the position vector is this. We want to find the speed. And then I should also notate on this that this one is a calculator question. So something like this, remember that speed is equal to the magnitude of the velocity. So you'd want to find the velocity formula, so derive each. And then once you've done that, you're going to just stick it into your magnitude formula, and then that would just all go into a calculator. There'd be no way to actually do that by hand. So I don't need you guys to crank all that out right now. But this would definitely be something you would see in like the calculator multiple choice section, something like that. Okay. Let's see. Next, we have integrating vectors. So this is going to kind of take us back through differential equations when we do this. So when we integrate these, I would make a note to yourself here. We're going to work on each piece separately, or work on each separately. So if we have velocity and we want position, we need to integrate, right? So we're going to just treat this as two totally separate problems. So we're going to integrate t plus 1 to the negative 1 dt, and we're also going to integrate t plus 1 to the negative 2 dt. Okay, so first thing I'm doing here is going to flip this one downstairs. So that's 1 over t plus 1 dt. And on the other side, I mean, if you do flip that downstairs, that's going to be 1 over t plus 1 squared. Either way, on this other side here, since we've got something squared, I'm thinking that we need to do a u substitution for this one. So, because even doing that doesn't particularly help me. The second you make that a u, you're going to flip it right back upstairs anyways. So I would do u du dt on that one. And go from there. Okay, so now we're kind of treating these like differential equations, right? Once you've integrated both sides, each one of these totally separate problems, they're all going to come up with a plus c. And now we have this, now here's the key to this, guys, is that this initial position, what is the time at an initial position? When you have an initial something, that is t equals 0. So when you're doing this and you go to plug in the point for the one over here, this is the x side of the problem, and this is the y side of the problem. So over here, your point is going to be 0, 4. Over here, the point you're going to work with is 0, 3. Okay. See if you can go through. I'll give you guys a couple minutes. See if you can go through and get to the conclusion of this, and then we'll talk at about 9:05. Okay, so if we integrate this left side, that should have given us natural log, absolute value, t plus 1 plus c. And now that's really x of t, right? That's your position. So, and we already said that the point was going to be 0, 4. So that's going to be natural log of 1 plus 4. So that tells us that that's going to be 0. So c is going to be 4. So your position function is going to be natural log of t plus 1 plus 4. And on the other side, we're going to say that when we did this, that was going to be dt. So dt is du. So this would be us integrating u to the negative 2 dt. So when you integrate that, that's going to be u to the negative 1 over negative 1 plus c. And then if we clean that up, that's negative 1 over u plus c. And that's equal to y of t is our position function, but for the y part of this vector. And then what point did we have here? We said we were going to utilize 0, 3. So that's negative, well, let's plug back in first, sorry. Instead of u, let's call that negative 1 over t plus 1 plus c. Okay, and then we're going to plug in 0 for t, so negative 1. And then that's when we know the other piece here is 3. So when the position is 3, that tells you that c is equal to 4. Okay. So also over here, guys, that was the same thing. I just didn't really notate it. We were plugging in a better way. I kind of skipped ahead in my head. We're plugging in x of t. We were letting that be equal to 4. So this was 4 was equal to 0 plus c. And then that's how I'm coming up with c was being equal to 4. Okay. Same story here. Now that we know c is 4, that's going to be negative 1 over t plus 1 plus 4 is equal to y of t. Okay, so these are the position functions. And what are we looking for here? We're looking for the initial position at 4, 3. So if you plug in right here, find the position at t equals 3. So you're going to put a 3 into both of these equations. So that would be x of 3 is going to be natural log of 4 plus, and what do we know c is now? C is 4. And when you do y of 3, that's going to be negative 1 over, and if I put my 3 in there, that's going to be 4, and then plus 4. Simplifying that would be 15 over 4. Turn that to 16 over 4, right? So that those combine. And then you write it as a vector form. So this is going to be natural log of 4 plus 4, comma, 15 over 4. And that would be the final answer. I think you would see something like that in free response. If they gave you a vector like free response question, I think that would be kind of what you would be looking at. Do we have any questions on that one?
And can we still like utilize the no simplification trick for this one, or would we have to simplify?
Same deal. If it's in free response, you're totally good. If it's multiple
Okay.
choice, then you got to do what you got to do.
Right.
But like if it was free response, then like, yeah, this right here would be fine.
Yep.
Okay. Okay, so I don't want to take up your guys' whole night. That's the second piece to this. And then the next time we meet, we've got one more of these, and then I've got free response questions lined up that have been previously asked in vector stuff. So I think we'll only be like a half an hour the next time we meet, and that'll wrap up the vectors portion of the year. So all we have left is we got to do polar, and that'll take us about a week to learn about polar coordinates and polar derivatives and this and that. And then after that, we have to do sequence and series stuff, and that takes a long time. But other than that, we're getting there. And then as we start to round the bend, I'm going to find some college board stuff. They've got a lot of good videos and assignments. I'm going to just assign them to you guys and have you go through all of that as well. But anyways, we are getting there. So not going to do anything on your guys' spring break. You guys more than deserve to enjoy your spring break. So today's the 21st. So you guys are on spring break after Friday. That goes through all of, looks like Monday, April, help me out here on your calendars. Is there Easter's the third? The first isn't a holiday, right? We're okay on the first. Does that sound?
I
The
think we
first
have
we have the
off.
day off of school.
Yeah.
Okay. Are you guys okay starting there? Is that okay to get back together on the first Monday night? I don't want you guys to miss
I'd
too
be
many.
down.
Is that okay? Yeah, okay. So I'll send you guys remind messages to remind you, but then let's plan on our next meetup being Monday, April 1st. And then from there, you've got like 6 weeks till the exam. So that'll kind of start the home stretch. Okay. So if you guys need anything, as always, feel free to let me know. Hope everything's going well and enjoy your spring break. Go have fun. I will see you guys on Monday, April 1st.
Thanks. Happy spring break.
Yep.
Thank
See you
you.
guys.
Happy spring break. Bye.